Virtual Precal, I'm here to walk you through some of the troublesome review problems that you had. You can see the list here. Feel free to fast forward to what you're interested in if you like. Problem number 20. Whenever we have one of these that's the trig function of an inverse trig function, what I like to do is start out by thinking about that internal part, the inverse trig function, in this way. Inverse cosine of 1/4. Well, that's equal to an angle x. And that x, well, if we take the cosine of that x, we get 1/4. Okay, that means the same thing. Then we can draw a little triangle like the one you see here, and it works out that if the triangle has the bottom leg equal to 1 and the hypotenuse equal to 4, then look, the cosine of x is 1/4. Now we can ask ourselves, what is this third side, this vertical leg h? And we can use Pythagoras to find that. It's root of 15. And then we can construct from that what the sine of x would be, which is after all what we were looking for, and it turns out to be root 15/4. Okay, so this is guaranteed to show up. Practice this kind of problem if you need to. Number 33. Probably the quickest way to solve this is to first add 2 to both sides and divide by 4. So now we're isolating the trigonometric part. Then we can square root both sides, and we get that the cosine of x is plus or minus the square root of 1/2. I'm going through a whole bunch of steps here just to clear up for some of you that don't remember that the square root of 1/2 is root 2/2. So what we have is that the cosine of x is either plus or minus root 2/2. Don't forget the plus or minus. Whenever you solve an equation using square root, you have to have that in there. Now you guys know what the answers to these are. This is sort of 45 degrees, or pi/4, and any other of the angles that belong to the butterfly diagram for that. Okay? And so that turns out to be pi/4, 3pi/4, 5pi/4, etc. We can summarize that best by saying that x is pi/4 plus k pi, where k is any integer. Moving on to 37, this is harder. If we make the substitution here that u equals the sine of x, we can rewrite the original and make it look like a quadratic in a bit simpler form. This can't be factored as far as I can tell, so I use the quadratic formula, which is what you can see here. Simplifying what's under the radical, watch out for the double negative, you get 17. Okay, so x is equal to the inverse sine of those answers because u was the sine of x, and we're looking for x, so it's the inverse sine of u. Right, if we choose the plus, we get the answer 0.896 plus 2 pi n. If we choose the minus, it doesn't work out. Right, we get an undefined answer. Also, if we choose the plus, when you use inverse sine, you always have to watch out for the fact that the answer that you get, there's another answer, and it's going to be pi minus the answer that you get, and that's where the second red box comes from. So that's what I end up with, is those two sequences of answers in red. Okay, on to chapter 9. Number 13 was nasty. I see on the numerator and denominator of this fraction an opportunity to factor with difference of perfect squares, or DOPs. Okay, what I'm adding and subtracting on the top one is already squared, so it's confusing. But if you look carefully, cos squared and sine squared, I have the sum and the difference. If you multiply those back out and FOIL them, you'll see that you really do recover cosine to the 4th minus sine to the 4th. In the denominator, it's similar, but it's a little bit simpler. 1 and tan squared are the things that are added and subtracted. If you want, check me, FOIL that out, and you'll see that you recover 1 minus tangent to the 4th. Okay, so I'm just going to focus on this left-hand side. Now I'm going to use the trigonometric identities that I've written in red here. I'm going to replace cosine squared plus sine squared with 1, and I'm going to replace 1 plus tan squared with secant squared. Okay, so it's already looking a little bit better. Now I'm going to rewrite tan squared and sec squared in terms of sines and cosines, as you can see here. And then I'm going to distribute that multiplication in the denominator. So I end up with, in the denominator, 1 over cos squared minus sine squared over cosine to the 4th. Next step here is to make a common denominator for those two fractions that are already in the denominator. And the common denominator is cosine to the 4th. Once I do that, I can combine them into one fraction. Then I have a fraction divided by another, which, as you can see here, is the same as the first fraction times the reciprocal of the second. That crazy stuff, cos squared minus sine squared, cancels out, and I'm finally left with cosine to the 4th over 1, or cosine to the 4th, which is what, after all, I was trying to prove. So this is really hard. There are a lot of steps. Go back and look at it again if you need to, but I think you can do it. Just break it down and take it one step at a time. Number 19. This is also kind of hard. We have sum and difference cosine identities that we can use here, right? From section 9.2, I think it was. And so I've expanded the left side of our original identity as these two huge brackets here. Then I have to FOIL these things. I keep the cosine squared x, cosine squared y, and the minus sine squared x, sine squared y. The two cross terms, I've written one over the other here. As you can see, they're equal and opposite and they cancel. The next step is really tricky. Cosine squared is the same as 1 minus sine squared. This is an inverted sort of version of the Pythagorean identity. If I replace my cosine squared y, how did I know to do that? Well, if I look at what I'm trying to get, I don't want a cosine squared y. So I'll try to replace it with something and see what happens. If I replace it with 1 minus sine squared y, I end up with this. Okay, multiplying through, I see that it looks like this. Factoring out minus sine squared from the last two terms, I end up seeing that, in fact, this whole thing does work out. All right, so the secant of pi minus x, huh? Well, that's 1 over the cosine of pi minus x. Using the difference identity for cosine, I see that the cosine of pi minus x is the cosine of pi times cosine of x minus the sine of pi times the sine of x. Working out what I know there, that's just the negative of cos x. So the secant of pi minus x is nothing more than 1 over the negative cos x, which is the same as negative 1 over cos x. 41. I know the sine of x, and I know that that x is in the first quadrant, and I'm looking for the sine of 2x. Well, here's my double angle identity for sine, and here's the Pythagorean identity, which I can use to find the cosine of x. This is what I've done here. It turns out to be plus or minus 0.8. But I know that x is in the first quadrant, so it's got to be the plus. Then inserting all my ingredients here, multiplying through, I find 0.96. Good luck, guys. Keep the questions coming, and yeah, good luck on the test.